Good morning everybody. This is our third video of the chapter metal and non-metal. In the previous videos we have studied about the physical and some chemical properties of metals and non-metals. Physical properties like malleability, ductility, etc. and chemical properties, reaction of metal and non-metal with oxygen and reaction of metal and non-metal with water. Today we will study about the third reaction, that is reaction of metal and non-metal with acid. So first of all, reaction of metal with acid. Some reactive metals react with acid, like sodium. When reacts with acid, it reacts vigorously. It may an accident when we add sodium to hydrochloric acid or sulfuric acid, but we can add a small piece of magnesium to dilute hydrochloric acid to form magnesium chloride, and in this reaction hydrogen gas is liberated, and this is an exothermic reaction. It is also liberated in this reaction. So next reaction is when calcium reacts with dilute hydrochloric acid, calcium chloride is formed along with hydrogen, and it is also an exothermic reaction. When zinc reacts with dilute hydrochloric acid, then zinc chloride is formed with the liberation of hydrochloric acid, and we can say that the reaction of a metal with acid is an exothermic reaction. If we consider calcium plus dilute sulfuric acid, then calcium sulfate is formed with the liberation of hydrogen gas, and heat is also produced. Zinc, when reacts with dilute sulfuric acid, zinc sulfate is formed along with hydrogen gas. It is also an exothermic reaction. Take some more examples. Like if we in the reactivity series, like sodium, potassium, calcium, magnesium, aluminum, zinc, iron, tin, lead. These all metals, when reacts with an acid, it forms their corresponding salt with the liberation of hydrogen gas. So the next reaction is aluminium plus dilute hydrochloric acid to form aluminium chloride with the liberation of hydrogen gas, and heat is also produced in this reaction. These all reactions are exothermic reaction. But when we go to the reactivity series downward, like copper, when reacts with, what happens when a small piece of copper is added to dilute hydrochloric acid? There is no reaction, because these all reactions are displacement reactions. Displacement reaction. So copper is less reactive than hydrogen, so copper does not displace hydrogen from this hydrochloric acid or sulfuric acid. You all see that in these reactions hydrochloric acid and sulfuric acid is used, but nitric acid is not used. And why nitric acid is not used in these reactions? When nitric acid is used in this reaction, then hydrogen is not formed here, water is formed here, because nitric acid is very good oxidizing agent. We already have discussed these nitric acid reactions of nitric acid in chapter 1 and chapter 2 as well. But to revise it, let's start the reaction of magnesium with, not dilute, it is very dilute nitric acid. Then magnesium, there are two metals, magnesium and manganese, which can react with very dilute nitric acid to form hydrogen gas. Very dilute nitric acid to form hydrogen gas. And the product is magnesium nitrate. This is magnesium nitrate plus hydrogen gas. Water is not formed here, here hydrogen gas is formed. Because magnesium and manganese, these two metals are very good reducing agent. Reducing agent. So, with manganese forms manganese nitrate along with hydrogen gas. Some metals like copper, zinc reacts with reacts with concentrated sulfuric acid to form copper sulfate, water and sulfur dioxide gas. But these type of reaction we will discuss in metallurgy topic. So these are the reactions of metal with acid. Now second is reaction of non-metal with acid. Acid here nitric acid. Some non-metals react with nitric acid to form corresponding acids like when phosphorus reacts with concentrated nitric acid. Concentrated nitric acid. It forms phosphoric acid, water along with liberation of a brown fume, nitrogen dioxide. The color of the nitrogen dioxide is brown. Sulfur, when reacts with concentrated nitric acid, then sulfuric acid is formed along with water with the liberation of nitrogen dioxide. Brown fumes of nitrogen dioxide is liberated in these two reactions. These are the reactions of metals and non-metals with acids. Now, reaction of metals and non-metals with base. Our fourth reaction is reaction of metal with base. As non-metals usually do not react with base. Our fourth reaction is reaction of metal with base. As we already studied in chapter 1 that when zinc reacts with sodium hydroxide, the base needed here should be alkali. The base needed here should be alkali. You can react zinc with potassium hydroxide also. So zinc plus potassium hydroxide, sodium zincate, Na2 ZnO2, and zinc with potassium hydroxide also, potassium K2 ZnO2 with the liberation of hydrogen gas. Hydrogen gas is liberated in these reactions. These two reactions are slow reactions, not vigorous or very fast reactions. And the name of this compound is sodium zincate. And this is potassium zincate. You must draw the structure of these two compounds in white page of your notebook. Like sodium zincate. This is for sodium zincate. Na2ZnO2. Zinc has two valency. So one valency of zinc combines with oxygen, and oxygen has two valency. So these two valency of oxygen first combine with zinc and other combines with sodium. Likewise ONA. So this is Na2ZnO2. This is sodium zincate. And for potassium zincate, it is K2ZnO2. So for zinc, the two valencies, oxygen, and there is potassium and potassium. These two are the structures of potassium sodium zincate and potassium zincate. The next reaction of metal with base is with aluminium. With aluminium. Aluminium plus sodium hydroxide, sodium aluminate, NaAlO2. Here sodium is only one sodium, NaAlO2, with the liberation of hydrogen gas. And this is called aluminium zincate, sodium aluminate, sorry, is sodium aluminate. And the structure of sodium aluminate. Aluminium may also reacts with potassium hydroxide also, but just look at the structure of sodium aluminate. Aluminium has three valency, and aluminium here is in covalency. Aluminium reacts with one valency of aluminium combines with oxygen, and two valency of aluminium combines with another oxygen. There is three valency of aluminium is completed here, then sodium. So it is NaAlO2. This is sodium aluminate. Our next reaction, reaction 5, is for reaction of metal with salt solution. Salt solution. You know very well this reaction, these type of reaction. We already have studied under displacement reaction. First reaction is calcium plus zinc sulfate. Calcium sulfate plus zinc. Which type of reaction it is? Here calcium is solid, zinc is aqueous. Solution of zinc sulfate and solution of aqueous, so calcium sulfate is formed along with solid deposition of zinc. This reaction takes place because calcium is more reactive than zinc. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. So calcium is more reactive than zinc. So with the reaction of zinc sulfate and calcium, calcium displaces zinc from its place and takes the place of zinc for calcium sulfate. This the type of reaction is displacement reaction. Potassium is at the top of the reactivity series. I may blunder sometimes that sodium plays the place of sodium in the upper hand, so ignore that. Next is zinc plus copper sulfate. Aqueous solution of copper sulfate, solid zinc forms zinc sulfate, aqueous solution of zinc sulfate and reaction of iron with copper sulfate. Copper sulfate solution. Iron solid forms ferrous sulfate, aqueous, the color is light green with the formation of solid copper. Next reaction is reaction of Fe plus PbCl2, aqueous solution of lead chloride plus iron solid forms FeCl2 plus Pb solid. This is aqueous solution. Lead is grayish black. Grayish black. So these are the some reactions of, if we consider in this reaction of copper with zinc sulfate. Is there any reaction? Reaction of solid copper with zinc sulfate. There is no reaction, because in the reactivity series copper is less reactive than zinc. Zinc is more reactive. Now, these are the reaction related to the salt solution. Reaction of metal with salt solution. Now, what is aqua regia? Come to the aqua regia, which is also called royal water. Aqua regia is also called royal water. What is aqua regia? It is freshly prepared. You must remember this, freshly prepared solution of 3 part HCl and 1 part HNO3. The 3 part HCl is concentrated hydrochloric acid and concentrated nitric acid. When these two combines, they form NOCl plus H2O plus Cl. This Cl only, not Cl2 here. This is Cl. This Cl is called nascent chlorine. Nascent chlorine means chlorine is in its atomic form. It is very reactive, highly reactive. It is very reactive. It readily reacts with silver, platinum or gold to form their chlorides. So these two are, this aqua regia is freshly prepared 3 parts of concentrated hydrochloric acid and 1 part concentrated nitric acid, and this compound is called nitrosyl chloride. So 2 chlorine is formed in this reaction and balance this reaction. This is aqua regia. Why aqua regia is freshly prepared? Because if you prepare, these two mixture are combined and you left this mixture for some time. After some time, this two chlorine combine together to form Cl2. Then there is no effect of chlorine gas or chlorine molecule to the gold or platinum. So when this chlorine, if it is gold, then this chlorine combines with this and form AuCl. So you must remember the nascent chlorine. Nascent chlorine is its atomic form, which is very reactive. This is aqua regia. These are the total terms reactions, total chemical properties of metals and non-metals. Now, there are some questions. why some metals floats on water when we add a piece of it into water? Why some metals floats in water? When you add a piece of magnesium ribbon, if it is magnesium ribbon, to hot water, it starts floating. Or if you place a piece of magnesium in water or acid into dilute HCl, a piece of magnesium ribbon in dilute HCl, it starts floating, because as soon as you drop the magnesium ribbon into the hydrochloric acid, it starts reacting and hydrogen gas is formed. These bubbles is hydrogen gas. Hydrogen gas is formed here, and it traps the metal. Here also it traps the metal, and due to this hydrogen gas is very light, so it with this hydrogen gas it starts floating. Therefore, due to formation of hydrogen gas, it traps the metal piece and starts floating. Okay, thank you.